For more than 75 years, schoolchildren around the world learned that our solar system had 9 planets, with Pluto sitting quietly at the very edge of our cosmic neighborhood. Discovered in 1930 by American astronomer Clyde Tombaugh at the Lowell Observatory in Flagstaff, Arizona, Pluto was instantly celebrated as an astronomical marvel. However, from the very beginning, Pluto was an anomaly. Its orbit was strange, tilted at an unusual 17-degree angle, and so eccentric that it periodically crossed inside the orbit of Neptune. As the decades passed, improved astronomical measurements revealed that Pluto was far smaller than initially estimated, even smaller than Earth's own moon. In 1992, astronomers made a landmark discovery that fundamentally transformed our understanding of the outer solar system: the existence of the Kuiper Belt. Far beyond the orbit of Neptune lay a vast disk of icy planetesimals, comets, and frozen debris left over from the dawn of planetary formation. As telescope technology advanced rapidly through the 1990s and early 2000s, astronomers began detecting hundreds, and eventually thousands, of frozen bodies sharing Pluto's neighborhood. Scientists were forced to recognize that Pluto was not an isolated planetary giant, but simply the brightest discovered member of an enormous frozen swarm. The critical turning point arrived in January 2005, when astronomer Mike Brown and his research team at Caltech discovered a distant object named Eris. Initial observations revealed that Eris was approximately the same size as Pluto and possessed 27% more mass. The discovery triggered an immediate scientific debate. If Pluto was a planet, then Eris, along with other large Kuiper Belt objects like Haumea, Makemake, and Sedna, had to be classified as planets as well. Textbooks faced the prospect of listing dozens or even hundreds of new planets, prompting the global astronomical community to finally establish a formal definition. In August 2006, the International Astronomical Union gathered in Prague for its General Assembly to vote on the first formal, scientific definition of a planet. After intense debate, the Assembly established 3 mandatory criteria. First, a planet must be in direct orbit around the Sun. Second, it must possess sufficient mass for its self-gravity to overcome rigid body forces, pulling it into hygrostatic equilibrium, or a nearly round shape. And third, it must have cleared the neighborhood around its orbit of other competing celestial bodies. While Pluto easily satisfies the first 2 conditions, it directly orbits the Sun and has enough gravity to be spherical. It fails the third criterion completely. Pluto shares its orbital zone with thousands of other Kuiper Belt objects and accounts for only 0.07% of the total mass in its orbital neighborhood. By comparison, Earth possesses 1.7 million times the mass of everything else in its orbit combined. Because Pluto has not cleared its neighborhood, it cannot be considered a major planet. Rather than removing Pluto from scientific relevance, the IAU established a brand new category, dwarf planet, with Pluto serving as the archetype. In July 2015, NASA's New Horizons spacecraft conducted the first historic close flyby of Pluto, returning breathtaking images that stunned scientists worldwide. The spacecraft revealed towering mountains of water ice, smooth nitrogen glaciers in Sputnik Planitia, and a complex blue atmospheric haze. Pluto proved that dwarf planets are vibrant, geologically active worlds that continue to expand our understanding of the cosmos.